Hi and welcome to another Facebook Live session. This time it will be on spatial visualization. Oops. Hi and welcome to another Facebook Live session. This time. Okay. All right, thank you, Doris. Hi, Kok Kyung, Lina, Veron, Surin, welcome. So this is Kevin from Maths Heuristics. We will be discussing on spatial visualization today. If you have downloaded the notes, you would see that there's a lot of examples, so I would make this introduction very brief. So about myself, I started teaching in Maths Heuristics since 2011. Started out as an intern, graduated from Nanyang Technological University with a degree in mathematics and economics. So for myself, I have first-hand experience on dealing with difficult questions because when I first started out, I know how to do it, but to explain to the kids is a totally different ballgame. So I was mentored by Mr. Sani Tan, who founded Maths Heuristics back in 2008. And after that, I just kept on teaching ever since. Okay. Now let me give you a brief overview of spatial visualization. So here is the content list taken from the book. So I believe some of you have it because I see some familiar names who came from my webinar. I won't say who. Hi, Huang. Hi, Patricia. Thanks for joining. So today, out of the 6 techniques that is in spatial visualization, the first one is rearrangement of parts. Second one is drawing of lines. Third one is overlapping parts. Fourth one is the difference in area. Fifth one will be on ratio, dealing with units method. And the 7th one will be on visual clues. Mainly, I'll be covering this, and this for today. Why is that so? Because I want to go for quality rather than quantity. Okay, so these are the 4 main things I'll be covering from our spatial visualization book. Okay, so let's begin. Okay. All right. On the first example, you will see that this figure is made up of a semicircle, a quadrant, and a square. And the area of the square is 784 cm squared. We are to find the total area of the unshaded parts. So to do this, when the child first looks at this question, they want to try to find the areas individually, but you cannot do that because it is rather complicated. I mean, it can be done, but it will take you a very long time to find this individual area, this individual area, and this individual area. It will take you a very long time to do that. So this question can be done within 1 step alone. So how do we do that, and how do we understand this problem first? Now the key thing here is on the rearrangement of parts. How do we rearrange it in such a way that we can use the formula learned in school to calculate the area? So the way to do it is this. All right? Okay, maybe I think I'll use yellow here. Okay, if I use yellow, would it be brighter? Okay. Okay, anyway, I think yellow is good because it works well against a dark background. Alright, the key thing here is we want to rearrange it in such a way that we can use formula to calculate. So the first thing I would do is I would draw a diagonal line across, move this guy over here. It fills up that space quite well due to symmetry. And then I would move this guy over here instead because the diagonal line of the square cuts it into exactly half. So you can rotate it to fill up that space. And once we have done that, the net shape that we will obtain is that this top part will be shaded. Okay, thank you. 悠游自在, thank you. This part will be shaded, and this part will be shaded. So effectively, because all these are identical triangles, if you cut them at the diagonals of a square, you will have 4 identical triangles. So we can say that 1 out of a total of 4 of the square is shaded. So 1/4 of the area, 784 cm squared, would just be 196. So there you have it. It can be solved by a one-liner when you know how to rearrange it. Okay, answer here is 196 cm squared. Hello, Diana. All right. Now next up, example 2. This was the question I posted on Facebook. Okay, the diagram shows a circle with a center O, AB and XY are the diameters of the circle. So AB is here and XY is here. They are the diameters of the circle of length 10 cm. Okay. Find the area of the shaded parts, taking pi to be 3.14. Okay. Now, coming back to what I elaborated in example 1, you want to rearrange the shapes in a way that you can calculate. Because when you first look at this problem, your first chain of thought would be to find out what this area is, would be to find out what this area is, and this area. However, there are no formula that can find out these areas at the primary level. But what they can do instead, the students can do instead, is to group them or rearrange them in a way that they can calculate the area. So the first way to do it is this. We want to put this shaded region over here. After I have done that, this part would be filled up. Right? The second thing is, now I'm only short of this little gap here to fill up this space, and then I would have a semicircle on this side. So what else can I cut out? The next portion that can be cut out is if I were to measure 2.5 cm from this line AB, draw this line down here, I need to cut out this portion and put it over here. Doing this gives me a semicircle at the lower part of the shape. So when that happens, this is what I will have. This region is shaded, and then I have a rectangle whose total length now is 5 cm and the breadth is 1.4 cm, which is also shaded. So the area of the shaded parts, let me go through this real quick, would be half of the circle, half times pi, 3.14, times, because the diameter length is 10, the radius must be half of that. That will be 5. So this is the area of the semicircle, plus the area of the rectangle, which is 5 times 1.4. This will give you 46.25. So the answer here must be 46.25 cm squared. Alright? Hello David, Eason, and Janet. Thanks for coming back. Okay. Alright. Is everyone following so far? If you are following, please give some likes, so that I know that you're still there. Alright? Okay, thank you, Janet. Okay, so need to rush through already. Then on to example 3, the difference in the area. Problems like these have also been popping up quite recently, but quite sporadically, I would say. Now, when you first see this problem, the figure below shows a square of side 10 cm. So obviously this one would have to be the square. And triangle overlapping each other partially. So this is the triangle that they are referring to. Given that the area of the triangle is 65 cm squared, find the difference between the two shaded areas. Now, the thing here is, if I tell you you only need 3 necessary steps to solve this problem, would you believe it? Wait, for this problem, there's only 2 steps. Now, the thing here is, the area of the square would be 10 times 10 to be 100. We take 100 and minus 65, and then we have 35. Then the answer here must be 35 cm squared. You only need these 2 lines at most. So the next question is, how do we come to this? Alright, you see, when you first see this problem, the first thing that will pop up to your mind would be to find this shaded region, this area, and minus away this area. Correct? But then there is no information about this triangle here. So there's no way you can find the shaded areas alone. The key thing lies in difference, because when you are finding the difference, usually there is one concept that they need to link back to, which is on elimination, grouping and elimination. So this is what I'm going to do. Okay, let me call this part A, and let me call this part B, and let me call this part C. So if I were to draw out the model between A and B, this represents the area of the entire square. Next, if I were to draw out the area of the triangle, I want to put my B over here because it is the repeated item. Then, it is clear that the difference between A and C lies over here. True? Okay, let me reply to someone. Okay, digest that first. Okay, so this difference is actually AB is the area of the square, which is 100. CB is the area of the triangle, which is 65. And that's how we came about to getting this 35 over here. Okay? So now let me move on to number 4. Okay, in the same idea, with the same idea, we can apply it to a question that is tweaked slightly. So the figure below shows a rectangle ABCD measuring 10 cm by 8 cm and a triangle CEF. So given that DF is equal to 2 cm, FC is equal to 8 cm, find the difference between the two shaded areas. So from the trick that we learned earlier, let's call this region X, this region Y, this region Z. Okay, first I know that my rectangle ABCD is 10 cm by 8 cm. So the area of the rectangle is quite easy to find. That is just length times breadth, which is 80. As for the triangle, how are we going to find its area? So here it is not so obvious. But if you were to extend out this base and extend down this height, you would see that its perpendicular height is actually 8 cm. So once we got that, this area will be, the area of triangle CEF will be half times base 8 times height 8 to give you 32. Once we got that, if we are to draw our models and see it, the area between X and Y is 80. The area of Y and Z, so since Y is the repeated item, put it together, then we put Z over here. This is 32. The difference in area between X and Z can then be isolated and found. So this will be 80 minus 32 to give you 48. And then the answer here will be 48 cm squared. Alright? Okay, let me try something. Okay, so if you got it earlier, please give some likes if you understand. If you don't understand, please let me know. I'll try to adjust my pace. Although I have a feeling today we will overshoot because of the glitch earlier. Alright, great. It's good to see many of you understanding what I'm teaching so far. Some are also laughing. Okay, so now let's go on to number 5, drawing of lines. How do we find the area of a square whose diagonal is 12 cm? So as parents who probably studied mathematics in secondary school and above, the first thing that will come to your mind is Pythagoras theorem. Okay, I'll just call it PT for short. Then you'll say that this one, let this be A, let this be A also. So A squared plus A squared is equal to 12 squared. And then you say that you try to find 2A squared equals to 12 squared. A squared is equal to 144 divided by 2, which is 72. Then after that, you end up with this square root thing. Okay, the thing here is at the primary level, they have not learnt about Pythagoras theorem yet. So let's get rid of that. How are we supposed to do this or explain it to a primary school student? Its diagonal is 12 cm and this is a square. So coming back to the first question's idea, if we are to draw out another diagonal from the opposite side, this would cut it into 4 identical triangles. And we know that this would be a right angle. And it cuts it at the middle point of the square. So this becomes split into half of its length, 6 cm and 6 cm. Once we got that, each of these triangles have a right angle here. So its base can be thought of to be 6 cm, its height can be thought of to be 6 cm as well. So once we got this, we know that there are 4 identical triangles. There are 4 copies of half times base 6 times height 6. That will give us 72, and this will be the answer, 72 cm squared. So this idea is important because sometimes questions will not be as direct as this. Sometimes it may be subsumed under another question involving circles. This one I will not go through. I'll briefly show you the idea on how to solve it. So in this problem, as you can see, first you have a square. Second, you have this quadrant here. And then you have this triangle whose length is unknown, but you can infer that its diagonal is 10 cm, and then from there you find the area of the quadrant and you get rid of this triangle. So that's how you get the answer. I won't go into detail for this. Because I need to move on. So if you do understand, please give some likes so that I know. Well, a lot of you got the answer even before I explain it. Very good. Irene, Raven, David, Eason, well done. Hello, Kadambari. Hello. Okay, great. So most of you understand. Let's move on. Number 6. This problem used to pop up a lot around August last year. So I'll explain how it's done. It's very similar to the difference in area idea. Okay, because you don't have to find the individual components. Now, if you look at this problem, the figure shows two identical right-angled triangles overlapping each other. The word identical is usually overlooked, but it is extremely necessary in solving this problem. That's why I highlighted it for you. They are overlapping each other. We have to find the area of the shaded part. So when you look at this guy, this shaded part, it's a trapezium. And you are given this slanted height, which is 6 cm. At the primary level, they will not have learnt on how to deal with trapeziums yet. And even if I were to cut them up, I can't find anything of worth. So the way to approach this is to see that because both of them are identical, this triangle underneath it will be somewhere here. The edge of the triangle will be somewhere here. Okay. So, since all of them are identical, let me call this part A, let me call this part B, and let me call this part C. The area of A and B must be equal to this triangle as well. Okay, this triangle as well, because they are identical. So, in other words, put the B together, repeated items, try to put them together, then put the C here. So, in other words, the area of this segment A is equal to C. Once you are able to see this, we can find A to find C, because you cannot find C directly. So we find A instead. Oops. Okay, let me shift the wording. But we see that A is a trapezium. Well, that's not wrong. It is a trapezium. So how do we find its area? Here we have to draw out the lines as well and cut it into two segments. First, a rectangle. Top part here is a rectangle, and then a triangle over here. So since this length is 16 and this length is 6, this length must be 10 cm. So from that rectangle, it is now a special case because its lengths are equal. It is now a square. So the area of this part will be 10 times 10. The top part will be 10 times 10. And the bottom part will be half times base 10 times perpendicular height 6. Now this will give you 130. The answer here must be 130. cm squared. Alright. Okay, so did everyone get it? Okay, more importantly, did everyone get the idea? Because here you cannot find the shaded part directly, we have to visualize it in some way. It is shifted, so the area of A is equal to the area of C, so we find the area of A itself. Then we are done. Okay, so now the last one. Either example 7. So here, problems like these are also very common these days. Let me just make it smaller first. Okay, now the ratio of the area of the shaded region to the area of the triangle is 2:5. Allocate your units like what I've been telling you all along. It also works for spatial visualization questions like these. Shaded region to triangle's area is 2:5. Ratio of the shaded region to the area of the rectangle is 3:10. Okay? Now, we know that the area of the triangle is 144 cm squared. We have to find the area of the rectangle. So here, there's a lot of ways to organize your information, but what I recommend is this. Label down first, you have your rectangle. Now then my triangle first, then your rectangle. That total area, the shaded areas, and the unshaded areas. Alright, so once we have this, we will allocate the units and parts respectively. Shaded region 2 to triangles 5 means that out of a total of 5 for the triangle, 2 is shaded, which means that 3 units will be unshaded. For the rectangle, this shaded region is 3 out of a total of 10. Okay, then its unshaded region will be 7. Now once I have done that, okay, if I had time I would have let you talk through this. When we look back at this figure, maybe I use something else, not bright enough. When we look back at this figure, we can see that this shaded region is shared between them. And in this case, the shaded region is the repeated item. And when they are repeated, we say that these two are equal, make them the same. So lowest common multiple between 2 and 3 is 6. So to get this guy to 6, the first row needs to be multiplied by 3, the second row needs to be multiplied by 2. Then this would become 9, this would become 15, this would become 20, this would become 14. So once I have made everything into a single unit, I can then use the information in the question. Area of the triangle is 144 cm squared, and the area of the triangle is 15 units. So we say that 15 units is 144 cm squared. 1 unit will be 144 divided by 15. That will give you 9.6. Then the area of the rectangle would be 20 units. That will be 20 copies of 9.6, which will give you 192. And hence, your final answer must be 192 cm squared. Alright? Well, I'm glad I made it. overshot a little, but I'm glad I made it. So if you do understand, please give some likes so that I can gauge the feedback. Alright? Yes, most of you got it. Yeah, Ethan, even when you don't understand, you still got the answer. 192, Raymond, yeah, good job, 192. David, 2, 192. Wow, so many people laughing. Yeah, man. Okay. Let me spam some for myself. Okay. Alright, good. That's great. Glad I finished on time. So this idea can also be extended and applied to questions with 3 shapes or more. Recently, the more common ones that I see on forums are the 3-shaped ones like these. Okay, the same ideas apply. You want to organize your information somewhat like this. Then proceed to solve it. Okay, you can try it out later. I will be going through this because I really don't have time really. So here's what we can do for you. And we at Maths Heuristics, we are a firm believer of the new Smart Nation initiative. And we are also moving in this IT direction. So we would be giving a parents webinar, Spatial Visualization parents webinar, to solve any of these challenging area and parameter problems for P5 and 6. So this webinar will be held on 11th of March, this Sunday, from 2 p.m. to 5 p.m. The fee is only $25 net. But then you'll be asking, what do I get? First, you get one solid session with myself. Second, we will support you with our integrated program. The ebooks, web videos, mobile apps, virtual classroom access, and VIP status in our Facebook group. So this is for $25. If you're interested in this, let me just type out the link real quick. Okay, the next one that we can offer you is the Spatial Visualization online program. So first, what will you get from this? You'll get the guidebook, hard copy, the web teaching videos, which will explain every single question in video format, Maths Heuristics apps, the virtual classroom, and VIP access to our Facebook group. So this is going for $49.90, and when you purchase this before Sunday, so the deadline is 10th of March, we will throw in the free access to the SV webinar on the 11th of March. Okay, so that's our second offer. I'll type this out real quick. ZAG8 cat M. And the third thing that we have is the holiday program. Our holiday workshop will be held on Wednesday and Thursday. Okay, so Wednesday will be for P6. This will be conducted by Mr. Sani Tan. And P5, 15th of March, 2 p.m. to 6 p.m. will be conducted by myself. Okay, so if you are interested in this, here's the link. And when you do sign up for this, although I would tell you the cost, what is the cost of all this later, when you sign up for this course, you would get the parents webinar, free access to the parents webinar for 11th March 2018. Second thing you will get is the online program for spatial visualization. So all this would only cost you $120 for a one-day workshop. So the deadline for this webinar, you need to register by 10th of March 2018. Okay? So let me type out the link real quick. Yeah, why can't I pin this? Okay, wait. So if you have questions, I'll gladly take them now. Okay, for Janet, Janet is asking, is this for kids? No, the parents webinar is for the parents, because for that I'll be covering the questions rather quickly and quite intensively also. And the learning pace for adults and children are different. So I'm trying to design these programs to cater for different learning paces. Okay? So are there any other questions? Okay, let me just wait for more questions coming in. Okay, please give some likes before you go. And thank you all for joining in. Okay, so Yin Yi Wong is asking, what is the SV online program? The SV online program consists of the hard copy book for the spatial visualization book, the web teaching videos, which will go through the guided examples, and all the exercises inside it, explained by myself. The Maths Heuristics app will be a mobile app that you can download on iOS or Android. Then this is more interactive. It's catered more towards kinesthetic and tactile kids learning profile, because for them they tend to be more hands-on. It will also control the flow of information at which they can take their time to digest. So if let's say you have a certain choke point that you don't understand, instead when you read the book, you tend to overlook it and you think that you understand. But when you look at it step by step, it may not be the case. You will be like, why is this step here? Why is this step necessary? For virtual classroom, this will be consultations with myself, but you have to arrange it 2 working days in advance on the books, the publications that we have. Okay, then for the Facebook group, this one will be VIP access. When I say VIP access, I mean it. Okay. So it is catered more towards independent learning. The access time will be for 6 years. If you have another child who will be in P5 or P6 in 6 years' time, you can still use this for them. Okay? How to register for student workshop? Okay, so Doris is asking, have to register online for student workshop? Yeah, the answer is yes. Yeah, for P6, I can tell you the seat is filling fast. The maximum for P6 will be 13. I can't tell you how many there are filled up now, but it's more than halfway there. Yeah, so I need to let you know that first. Okay, Yo Zizai, thanks for joining. So Doris, you can use this link here. Not sure why I cannot tag the thing. Hang on, let me find out how to. Okay, found it. Okay, any other questions? Okay, please give some likes and share it with your friends if you found this useful. The share button is only at the lower left-hand corner of your screen. You can't miss it. Okay? So it's 9 already. Thanks for rejoining me, even though there was some technical glitch that happened earlier. Like I said, this session is, I must be really lucky because I conducted, this is my 25th one, and it happened on the 25th one after so long. Okay? So thank you all for joining. This is Kevin from Maths Heuristics, signing off. See you soon.